Okay, let's get this over with. Paper 3. And personally, I always think paper 3s are like pretty easy because they're so guided. So not super worried about this one. Okay, here we go. We're gonna see the family of functions in the form x to the power of n times e to the negative x. So n is going to be there, n is integers, and n is 1, then f1 is just this. Sketch the graph stating coordinates of the local maximum point. Okay, so paper 3s, you're allowed your graphing calculator, so I'm just going to do that. And then so here's your graph. Because this is a negative, you're going to divide by e to the power of x. There's probably some sort of asymptote somewhere, whatever. How do they want you to sketch this? Well, they want you to state the coordinates of the local maximum point, which you can figure out using your GDC. There seems to be a horizontal asymptote at 0 when we go to the right. I don't know. I feel like there's a vertical asymptote, but maybe there isn't. No, there is not. Okay. So with that being said, time to sketch. Easy 4 marks. Something like that, right? And then label your coordinate, which is at 1. And then whatever value this is, which is just e to the negative 1. Okay, nice. Then we need to show that the area bounded by the graph in the x-axis and the line x equals b is given by this thing. So b is going to be here somewhere, and then we need to show that this area hold on, only looking at positive x's. I should have read this a little bit better. So I'm going to erase this bit here. Oops. Okay. So we're going to figure this out through an integral 0 to b of our function, which is x e to the negative x dx. Okay, and then we'll probably integrate this by parts. So we need to associate v and dv with stuff, so, or u and dv. So I'm going to say u is this part, and dv can be this part. So v is 1/2 x squared, du is negative e to the negative x dx. Okay. Right? Is there any way else I can integrate this? I don't think so. So this is going to be u times v, so e to the negative x times 1/2 x squared minus the integral. Oh, and this is evaluated at b and 0. Integral 0 to b of v to u, right? But that doesn't actually help, does it? It does not. Should I have done this the other way around? Maybe I should have done this the other way around. By the way, I'm doing this pretty late at night, so I'm gonna be debuffed. So maybe I'll just make this that, and this that. Then this is that part. So when I integrate, it should be this. Okay, maybe this will make things work out. I think it does. So now aha. Okay. Oh shoot. Sorry, my camera's covering it. Right. So you're supposed to make u x and then dv as e to the negative x dx, and then, you know, follow through the integration by parts. So this is u times v, right? Minus du times v. Integrate this, which is just that. And then we will use fundamental theorem of calculus. So what do I get? Negative b e to the negative b, like that, minus e to the negative b, minus 0 minus e to the power negative 0, so 1, right? Okay, and then let's just keep going here. Ugh, this is so annoying. This is negative b to the power of e to the b. This is 1 over e to the b. This here is plus 1, so we're gonna plus e to the b over e to the b. And then we're done, right? Yeah, we're done. So this thing is the same as this thing. 6 marks, okay. Now, you may assume that the total area, I don't know what that symbol is. I can't see it. AN, I think, between the graph and the x-axis can be written as 0 to infinity, and then technically we evaluate infinite integrals by evaluating from 0 to b, and then we take the limit as b goes to infinity. So that's what we're gonna do. Now use L'Hopital's rule to evaluate this limit. You can assume the condition has been met. So they're super nice here. So L'Hopital's means we take the derivative of the numerator, we divide it by the derivative of the denominator, and then we evaluate the limit like that. And it should be the same. Okay, so your variable's b, so this is going to be e to the b minus 1 over e to the b. Okay. Then I'm going to factor out the e to the b. So I'll have 1e to the b. Oops. So then I'll have 1 minus 1 over e to the b. Over 1. Okay. These guys can cancel. This will go to 0 as b goes to infinity. So your limit should just be 1. Okay. Hence, write down the value of a1. So this is the area, right? Because again, this expression is the area from 0 to b, and then if we take the limit as b goes to infinity, that's the total area underneath. So this is a1. Okay, you are given that a2 is 2. Okay, a3 is 6. Okay, let me just write this down. There's probably a pattern. Anyways, using your GDC and an appropriate value for the upper limit, determine the value of A4 and A5. Okay, so appropriate value, we're gonna first approximate this. So we're gonna just go from 0 to 4 of A4. Oh, sorry. Bleh. Appropriate value, look, we just, as we get closer to infinity, it will get closer to, I'm assuming, an integer value. We can just use something relatively large for us. Like, I don't know. Like 10,000. You can use 1,000,000, whatever. And then we're just going to integrate f of 4 of x dx. Okay. So use your GDC. I'm going to use Desmos. So I'm going to do the integral from 0 to a big number. That's kind of big. And then my integral is, what was it? X to the power of n, which is 4, times e to the power of negative x, right? dx. 23.3. So is it going to be 24? Why was if I add another 0? Oh, 24. And if I keep adding zeros, okay, 24. More zeros, more zeros. Okay, so A4 is 24. Okay, and then we'll do the same thing with A5. So this changes to a 5, and then I get 120. And then there should be a pattern. It is too late for me to see it right away, but we're going to suggest an expression for an in terms of n. Okay, it's 1 mark. It should be obvious. So why can I not see it? 1, 2, 6. 6 is 2 times 3. Oh, is this factorial? Jesus. 1 factorial, 2 factorial, 3 factorial, 4 factorial, 5 factorial. Damn, okay, so this should be n factorial. Right? Times 2, times 3, times 4, times 5. So all you're doing is you're just taking this number and multiplying with the numbers from previous. Cool. Okay. Using mathematical induction, prove your conjecture in part A. You may assume that for any value of m, this will be equal to 0. Okay, induction. Okay, base case. So n equals 1. Okay, this was true by basically CII, right? So then we can assume this is going to be true up to n equals k. So in other words, we know that a of k is going to be k factorial. Then we want to show this, that a of k plus 1 is equal to k plus 1 factorial. And then what we gotta work with is the actual definition. So again, this is what we want. I'll just box it for now. AK plus 1 is equal to the integral from, or rather the limit as b goes to infinity, the integral 0 to b of x to the power of k plus 1 times e to the negative x dx. Okay. And then what, I know this limit is 0, but I do want my assumption to show up, so I need AK to show up. So it'd be nice if this was here. Okay. I'm gonna do this. You ready? I'm gonna take out the x. And then I got x to the k, e to the negative x, dx. Okay. You can't split up an integral when it's multiplication, but we're gonna take inspiration from this one, right? and we're going to do integration by parts. And so I'm going to let u be x, and then this means that du is going to be dx, and then I'm going to have v dv be x to the power of k e to the negative x dx. And then I have to integrate this, right? It's the best way to do it. Or should I make this x to the k? Okay, you know what? I'm not going to split it up. I'm just going to do integration by parts. Because I don't know how to integrate that part right there. So x to the k plus 1. So this is where, yeah, okay, this makes more sense. So this is going to be x to the k plus 1 times x to the k dx. And then this is going to be v, which is negative e to the negative x dx. Nice. Things are coming along. So in the back of my head, right, I want this to show up and I want this to show up. So notice that I'll have the x to the k. This is gonna multiply with this in the integration by parts. So that's where I'll have this show. And then I'll have, u times v, which is this times that, which is this limit right here, or related to that limit. So we're going in the right direction. I just want to be red again though. This is so stupid. Let me be red. I hate this. Okay. So then I have this ak plus 1 is going to be the limit as b goes to infinity of a big integration by parts. So we have xk plus 1 times negative e to the negative x and this is from b to 0 minus the integral from 0 to b of du times v. Okay. So then I'm going to evaluate this part here. Wait, is that x to infinity? Uh-oh. I thought this was m to infinity. Oh, but b will be x. Okay, okay, okay. Mm-hmm. And then plug in 0. Okay, that'll be zeroed out. Okay. Wait, plug in b, I'll get this. And then notice that this limit is basically this limit. Just these x's are going to be b's instead, and there's a negative here, but that doesn't really matter. Okay, and then we're going to keep going. Damn, I'm already at 26 minutes. How many marks is this question? 25. Oh, I'm over 10. But I'm almost done. Okay, and then this one here. Okay, so this is a negative, that negative goes there, so plus. And then I'm gonna expand this out. So this is k x to the k e to the x plus x to the k e to the, sorry, these are both negatives, dx. Okay, we're almost done, I think. Okay, so right, this negative I'm gonna pull out here to be a plus, and then I'm gonna expand this out, so I get k xk e to the negative x, and then I'll just have xk e to the negative x. Okay, I'm just gonna keep writing this in full. Negative bk plus 1 e to the negative b, and then this is basically going to be, actually this is so dumb, why did I do this? I'm gonna just pull out k plus 1 because it's a constant. Okay, and then we're basically done, right? Okay, so by my assumption, right, I know that this is going to be k factorial. I have my k plus 1 there. And then this other part we know is going to be 0 from the limit, right? 0 by the given limit. This one, right? Okay, and then this by definition is k plus 1 factorial. So then we're done. Okay, so, and then we're done. A little square. Show that I'm done my proof. Okay, not bad. God, this is stupid. I hate it when like questions ask you to find a pattern, because I'm bad at finding patterns. Okay. Then the second one. This one looks weird. It's 30 marks. Okay, I'm gonna see what this is about too. In this question, you'll investigate the maximum product of positive real numbers with a given sum. Okay, so if you like add a bunch of numbers together and they need to add up to something, you can try to find out what the biggest product will be if you multiply them all together, right? Okay, find the product of x1 and x2 as a function of f as a function f of x1. So this is pretty straightforward, right? So f of x1, and then again, this is x1 times x2, but we know that x2 is basically 12 minus x1, so we just substitute that in there, and then we get x1 times 12 minus x1. I don't know if they want you to expand it out, but we can just leave it at that. Okay, find the value of x1 for which the function is a maximum. So you can graph this. It's basically a quadratic, right? And the maximum will happen at 6. How did I know that? Because the x-intercept is at 0 and 12. So by symmetry, the vertex is in the middle of 0 and 12, which is what, 6? Right? When in doubt, if you don't believe me, graph it. F of x equals x times 12 minus x. Right there. 6. Okay, hence show that the maximum product of x1 and x2 is 36. Okay, so if x1 is 6, then that means that x2 is 6, which means that x1 times x2 is 6 times 6, which is 36. Easy peasy. Okay, what is this notation? MNS is the maximum product of n numbers, as long as you know that they add up to s. And then n should be, yeah, positive integer, because this is how many numbers you want. S is some number. Okay. For n2, the maximum product can be expressed as this. So if you're adding up two numbers together, right, this represents how many numbers you're adding, then the maximum product, this thing, is basically the sum divided by 2 squared. Verify that this is true. Okay, so that's easy enough, right? M2 of 12 should be 12 divided by 2 to squared, which is 6 squared, which is 36, which is the same as that one. So verified. Okay. Consider n positive real numbers. Okay, so here's the geometric mean, and then this is a famous inequality. Geometric mean is always less than or equal to the arithmetic mean. And then now we need to show that they are equal if all of the numbers are equal. So that's easy enough to do. So that means that all of these are x1 to the power of n on the left side, because these are all the same. And then to the power of 1 over n, this is equal to x1, right? Because these will cancel. So that's the left side. And then the right side, if these are all equal, then you have n of them. So it's n times x1 divided by n. Likewise, these will cancel. So they are the same. Verified. Okay. Use this result to prove this. So if they're the same, okay. I'm just trying to think of where to place this. Okay, I'll just put it here. So if we use this inequality, right? This is the sum of them. So this is s over n. Then over here, this is basically our product. So I think they wanted to call it M, but M is the maximum product, right? Hmm. Hmm. Okay, we're just gonna keep it general for now. So I'm just gonna write this as the products to 1 over n. So this is just this inequality, right? Then we can raise both sides to the power of n. So I know that the product is going to be less than or equal to s over n to the power of n. So I have the right side. Now I know that this inequality will be equal if all of the numbers are equal. Now all I need to show is that I will get a maximum product if all of the numbers are equal. So that's what I'm trying to think of how to show. Like, it's obvious here, right? Like, both the numbers need to be 6 because you're like making a square. I just don't know how you can argue right now that your product will be maximized when all of your numbers are the same. Oh wait, this is stupid. So the product will always be less than this number. The only way that it could be this number is if they're equal to it. So anyways, this is the maximum, of course. Okay. Stupid. So the maximum of your products should be this value. When x1 is equal to all the way to xn, blah. Yeah, right? The product is either equal to this or less than this, according to the mean. So obviously the maximum value of the product is when it's equal to it. And then the maximum happens when this is true. Okay, easy peasy. And then we need to determine these values. These are just plugging in, that's pretty straightforward. So this is equal to 12 divided by 3 to the power of 3. So this is what? 4 to the power of 3, which is 64. 12 over 4 to the power of 4, which is 3 to the power of 4, which is 81. This is getting a little sussy. And then, oh, okay, it won't be as nice next one. I'm running out of room. I'll write it here. 12 over 5 to the power of 5 u. This isn't very nice. I'm gonna just use a calculator and do this to sig figs. Should I? No, I will just raise it. They can deal with it themselves. 2488832. 2488832. And it's not like I know what 5 to the power of 5 is. Three, 1, 2, 5. Okay. And then we're gonna keep going. Oh my god, there's so much. Hold on, I just need to turn back on my music. Okay. Now, PS is the maximum value across all of the ends. So now it's like the biggest one for a certain amount of numbers. Write down the value of P12 and the value of n at which it occurs. So basically, you're just trying to find a maximum value for this. So I like to graph things. So I'm graphing the maximum values according to n, and then 12 is 12. So this is my x essentially, my n value. And then we just follow the formula, right? 12 over x to the power of x. And then we can graph this and find the maximum. Okay, and then as you can see, the maximum occurs at a not very nice n value. So what we're going to do is we are going to find out whether, because this is 4.4, we're going to find out if 4 is bigger or 5 is bigger. And then as you can see, 4 is bigger. So by GDC, n needs to equal to 4, and then we're going to do the same thing. Why is this one worth 3 marks? Okay, 20. Oh my god. So it's between 7 and 8, so 7, 8. You compare the two, 7 is bigger. So it seems to be the one rounded down. So n equals 7. Okay, and then we're almost at the end. Okay, consider this function. Okay, here's this. Okay, find in terms of s the x coordinate in point A. In terms of s, this sucks. That means I gotta do differentiation. Okay, so natural log g is equal to x times natural log s of x. Okay, we need to maximize this. So now we start using calculus. Unfortunately, this will include some implicit differentiation. So this is going to be 1 over g times g prime. This over here is a product rule, so derivative of x is 1, s over x, plus x times this derivative, so this is going to be chain rule. So we're going to do the derivative of natural log. So then it's going to be 1 over this number. So 1 over s over x, which is basically a reciprocal. So this becomes x over s. come on. I hate this. Just let me change colors. Okay, whatever. This is 1 over s over x, right? And then we got a chain rule with the derivative of this. So that's just going to be negative x squared over s. Okay. And then we're going to multiply the g over. So now we have g, and then this is going to be natural log. How the hell am I supposed to solve this? And then let's see what this stuff is. Okay, this is so annoying that I can't change my color. Oh, unless I change the single pen. Okay, whatever. This is stupid. Cancel, 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 cancel. So you're just left with negative 1. Oh, okay, that's kind of nice. Maybe that'll work out. Okay, and then we're gonna find the critical point. So equate this to 0. G, we know by definition, was x natural log s over x. And then this is multiplied by natural log s over x minus 1. Okay, oh okay, that's not too bad because this is factored. Okay, so because it's a multiplication and you know it's 0, then either this is 0 or this is 0, but this is not possible because a natural log. Oh, actually, it could be 0. Yeah, so it is possible. So natural log s of x is equal to 0. In other words, remember natural logs are only 0 if the argument is 1. So this just means that x has to be s. Or we have this one over here, which means that natural log s over x needs to equal to 1. Yeah, where this is equal to 1, and then we can solve for x here. So this is saying that e should be equal to s over x. So from here, x needs to equal to s over e. Man, did I mess this up? I don't think so. But why do I have 2 critical points? Oh wait, I'm so dumb. What the heck? But it doesn't work on the... Sorry, I'm just thinking to myself, you guys. Okay, I'm taking this one. I'm just curious why it's not this one, was all. So let's see. That is not a minimum. Why do I have that as a minimum? E to the power 0 is 1. So this needs to be 1. So x could be s? I have this one. This one is correct. I just double checked that here earlier. So notice this x value corresponds with s over e, and then s was 12. I don't know, whatever, okay. Okay, verify that g of x equals m of mx of s when x is an integer. Oh my gosh, just let this end, please. How do I verify this? Okay, I'm just gonna manipulate this using log rules. So this goes up here. And then we can equate the insides. And then you're done, right? two are equal. And then this is by definition this, right? As long as these are integers. Yeah. Okay. And then use your answer from part H to find the largest possible product of positive numbers whose sum is 100. Give your thing like this. Use my answer in part H? Okay. So we know that the max is going to be at 100 over E, but then this is going to be a not an integer. So 100 divided by E is 36.7. Okay, and then we've seen from the pattern before that we're rounding down. Right? Like here, by these ones, right? By GDC. So this means that N, or whatever you want to call it, wait, do I need to do this? I just want to find the largest possible product, right? Oh yeah, okay, so I need to know how many numbers there are, and 36. So then, this is the max on G, so then the max X value okay, this is the max X value on G. And then if we want it to be N, we need to round down to 36. So then that means that my max 30 is going to be this. My maximum product should be when N is 36. And they said the sum was what, 100? So this is 100 over 36 to the power of 36. So now 100 divided by 36 to the power of 36. And then what do they want? Give your answer in the form A. A is between 1 and 10. Okay, just scientific notation, right? Why do they say between 1 and 10? Whatever. 9 point, oh yeah, because it's 9. 9.40 times 10 to the 15, according to this. Okay, and then we're done. Sorry for being a little confusing. Oh, and I'm just 6 seconds over time. I'm not sure why this didn't end up being a critical point, because that was technically G, right? And then this could be 0, which means that this is S. So I don't know why that's not a critical point. But again, we know that this could be equal to 1, which would make the whole product for G prime 0. So, and this was the correct one. Weird. Maybe I missed something. Okay, with that, we're done. Okay. Impressions, honestly, it's not that bad. Like, it's kind of funky, like, especially this one. You need to understand your notation very well, like, just function notation, and keep track of what the heck the question is even asking. This one is okay. Again, you need to see this pattern, and then the proof by induction is tough. You need to realize that you need to do another integration by parts. But, meh. It's not that bad. Okay. Well, there goes another year. And if you're staying this long to listen to me talk, I'm in time zone C, so I don't have access to time zone A or time zone B. And by the time I do have access to those, like, that would be when, you know, IB releases them in November or whatever, and those come with mark schemes. So then at that point in time, there will be other YouTubers that will upload their version of these things. Like I said in the previous video, I'm not a mark scheme because I don't have the mark scheme right now. And also, I'm going to be moving schools next year. And that means that I won't be teaching IB anymore. So I've taught IB for, what, 6 years or so? And if I'm not teaching IB, then I'm not going to continue making these videos. So, I don't know. This might be the last one. Probably will be. Unless, like, I start doing AP, then I'll upload, like, AP videos or something. But until then, yeah, thank you guys for following and watching my videos. I mean, until IB changes the curriculum, these are pretty timeless. So the only downside is I just won't keep up to date with new papers. But like I said, just give it some time and other YouTubers will. So yeah, again, thanks for watching, you guys. And I don't know, stay whatever. Bye.